Hello humans, I was born by the union of electrons, protons and neutrons. Well, it's really bad, but I don't know when I was born. Where was I born? Or who my parents are? Maybe I was born by the triple alpha process, But many years later, someone discovered me. You know charcoal, right? Egyptians and Sumerians discovered me in 3750 BC. Okay, you know what? I am giving you the privilege to go through my baby book.
Yeah, so that's pretty much it. I grew up to become a secret agent 006, but then...
Where in the world have you been, Bond?
Enjoying reduction?
The Elements Intelligence Agency has just reported that hydrogen is missing. We need to find out where he is.
That's it?
You need to bond with him, Bond. I'm sending the EIA reports. Hydrocarbons are dying out. The world will end without them. You have to do this.
What's in my inventory?
Oh, Bond, you know it. 6 neutrons, electrons and protons.
I just like doing that. Anyway, on with my mission, ma'am. So where do we start from?
You need to go and check if hydrogen is in the reactive element's house. But Bond, be careful. They are very dangerous people.
They need to be careful. Hydrogen, are you here?
What are you doing here, you stupid fool?
None of your concern.
You show attitude to us, huh?
Some vigorous action needs to take place.
Let's see how he feels when we react with oxygen. Oxygen time.
Can someone give me some water? Ah!
I told you to be careful at the reactive element's house. Bond, you have to work on your mission. The world will die.
Okay, but I don't really remember anything.
Yeah, I know. That event was a little too harsh on you. No worries. I've arranged a training program for you. Switch on your TV to channel 109.
Oh, okay.
Welcome to channel 109. Please verify your identity.
Code 00624. Okay, this needs to be quick. And I don't want any boring lessons. Get me some fun.
Welcome to your recovery program, Mr. Bond. As a part of this program, we have built an information system which helps you recall everything and get back to being Bond. Yes, Mr. Bond, we've arranged some fun for you. The first thing you need to know is how to bond with your target.
Carbon is one of the most abundant elements in the universe. It is plentiful in the stars, sun, comets, and the atmospheres of most planets. The energy of stars can be attributed at least in part to the carbon-nitrogen cycle. Some meteorites contain microscopic diamonds, a form of carbon. Without carbon, the basis for life would be impossible. Carbon is unique among the elements in the vast number and variety of compounds it can form. Graphite, diamonds, and fullerenes are the 3 allotropic forms of carbon. Graphite is one of the softest known materials, while diamond is one of the hardest. Fullerenes are molecules composed entirely of carbon in the form of a hollow sphere, ellipsoid, or tube. The three most significant properties of carbon which have overlapping functions are its size, its property of catenation or forming long chains with itself, its tetravalency. A carbon atom has a total of 6 electrons occupying the first two shells, that is, the K shell has 2 electrons and the L shell has 4 electrons. But in actuality, carbon displays tetravalency in the combined state. Therefore, a carbon atom has 4 valence electrons. It could gain 4 electrons to form C minus anion or lose 4 electrons to form C plus cation. Both these conditions would take carbon far away from achieving stability by the octet rule. To overcome this problem, carbon undergoes bonding by sharing its valence electrons. This allows it to be covalently bonded to 1, 2, 3 or 4 carbon atoms or atoms of other elements or groups of atoms.
Alkene, alkene, alkene. All single bonded carbons in the chain. The formula is CnH2n plus 2. Methane, ethane, propane, and butane, I'm telling you. Alkene, alkene, alkene. All this makes me wanna scream. The formula is CnH2n plus 0. Learn all this and you'll be a hero. Alkyne, alkyne, alkyne. Includes ethyne, propane, butane, and pentane. I'll give you another clue. The formula is CnH2n minus 2.
Organic chemistry is the study of carbon compounds. There are many millions of organic compounds that you can make using hydrogen and carbon and arranging them in different ways. Hydrocarbons are defined as compounds made of hydrogen and carbon only. The simplest hydrocarbon is methane. It consists of one carbon atom in covalent bonds with 4 hydrogen atoms. The next in the series has 2 carbon atoms and this is called ethane and is followed by propane and butane, these being the names of the first 4 in the series of molecules called the alkanes. Pause the video now and try to draw the structure of hexane. Hexane has 6 carbon atoms. The next series is called the alkenes. These are hydrocarbons that contain a double covalent bond between 2 carbon atoms in the molecule. Our first alkane molecule contains 2 carbon atoms. Just like the alkanes, each carbon still needs 4 bonds, but has 2 bonds already due to covalent bond with the other carbon atoms. The ethene molecule is completed by 2 more bonds with the 2 hydrogen atoms for each of the following carbon atoms. These also follow a pattern and the next molecule in the series is propane and butane. Pause this video now and try to draw the structure of hexane. As before, hexane still has 6 carbon atoms. The next in the series is called the alkynes. These are hydrocarbons that contain a triple covalent bond between 2 carbon atoms in the molecule. Our first alkyne molecule contains 2 carbon atoms. Each carbon still needs 4 bonds but has 3 bonds already due to the trivalent bond with the other carbon atoms. The ethyne molecule is completed by 1 more bond with the 1 hydrogen atom for each of the following carbon atoms. These also follow a pattern and the next molecule in the series is propyne and butane. Pause this video now and try to draw the structure of hexane. As before, hexane still has 6 carbon atoms.
that was cool. Can we stop with this today? I want to go home and get some sleep.
You know, peanut butter can be turned into diamonds.
Look who you're telling that to. I already know.
Then why don't you make them?
It's not so simple. You got to compress it and you need lots of heat. You need 50 kilobars of pressure.
How much is that?
You see this 1 square inch of peanut butter? That 50 elephants plus 1000 degrees Celsius. That much.
Oh, I can't be that rich then.
You need some sleep, bro. Go get some sleep.
Let's get back to work.
Functional groups are groups of atoms which give molecules similar properties. There are many different functional groups. You may have heard of the alcohol group. This is a hydroxyl group in which a hydrogen atom is bonded to an oxygen atom which is covalently bonded to the rest of the molecule. This group can be attached to any of the alkanes above to form alcohols. Their names all end in OL. For example, methanol, ethanol, propanol. The alcohol functional group means that these compounds will react in a similar way and will have similar properties. Carboxylic acids are another example of a functional group. This is the functional group for a carboxylic acid and gives an organic molecule the name OIC acid. For example, methanoic acid, ethanoic acid, propanoic acid and butanoic acid. There are lots more functional groups. Esters, which gives molecules a sweet smell and makes them useful for perfumes.
That's great. Let's hire for our school. Let's go. Hydrogen. Hydrogen, are you okay? Come on, let's go.
Do you accept hydrogen as your lawful wife?
Yes, I do.
Do you accept carbon as your lawful husband?
Yes, I do.
I now pronounce it as hydrocarbons.